All right, today, guys, you are going to learn how to solve word problems using what you know about finding ordered pairs and graphing them. So the table below uses number patterns to describe the changes in the width and length of a rectangle. So X is going to be the width, and then Y is going to be the length. Plot each of the four ordered pairs in the table on the coordinate grid. What do you think the length is if the width is 5? So we're starting here with 111. The ordered pair for the very first beginning is 1, 11. So I am going to take one of the dots that I have on my thing here, and I am going to go over 1 and up to 11. So that is where I'm going to move that bad boy. That's my first plot. All right, the rule here says that we're going to add 1 each time. So the next x-axis is 2. So I'm going to take this dot, I'm going to put it on 2 here, and it tells me I need to go up to 10 because the second rule, or the rule for y, is that we are subtracting 1 each time. So the next dot is going to go over 3 and up to 9. And then my next dot is going to go over 4 and up to 8. Okay, so we need to figure out what the ordered pair, what the length is going to be if the width is 5. So that would just be continuing this graph. So we added 1, so the width is 5. So we need to continue to subtract. We're going to subtract 1 from the length. So that would mean the length is 7. So I solved that mathematically, but I could also just solve it using the points that I just graphed. So as you can see here, it's not a perfect line because y'all know I'm not ever perfect. But if you just continued this line, if you drew a line between these points with a marker or a ruler or pencil or whatever, and you kept drawing the line, you would see here that a length of 5, you went over 5 and up until you touched the line, which has now gone away, so not ideal. You would also hit 7. That is the right ordered pair, 5, 7. All right, so here is, come on, here we go. Oh my gosh. All right, so here is just another example. This is not what I'm wanting it to do. Both Ann and Bill earn the amount of money shown each week. Ann starts with no money, but Bill starts with $5. How much will Bill have when Ann has 30? Represent the situation using a table and a graph. So they each earn $3 a week. But Ann starts with 0, Bill starts with 5. So the rule here for this chart is to add 3 each time. So in week 1, Ann's got $3 because she had none to start, and Bill has $8 because he has 5 to start. And then you're just going to continue to add 3. So in week 2, Ann has 6, Bill has 11, add 3, add 3, add 3. So this is how much they have at the end of 5 weeks. This question doesn't even ask about number of weeks. It just asks how much Bill's going to have when Ann has 30. So we would need to complete this chart until you get to 30 and see where Bill's at. So you can do that by continuing to add, but you're talking about many, many, many more weeks, or you can plot on on a coordinate grid right here, draw your line, and it's just easier to see that when you go to 30 and you go straight up, you see that Bill has $35. Much easier than just doing all of that math over and over again. You just plot it, draw your line, and then find out where Ann's earnings are at 30, because that's going to coordinate to where Bill's earnings are at 35. So your classwork today is going to be to use problems to solve or use your coordinate grids to solve problems. This is just number 3. You only have a few questions today, not many. All this one is asking you is to find out what X and Y is. So you're just kind of doing things a little bit backwards. So obviously X is going to be 5. And Y is 200. So if you were to build a table for this, the title of the table would be, this might be easier if I just switch to text box. The title of the table would be jet car distance. Let me input a table here. How many points do I have? 1, 2, 3, 4, including the title, and then 3. Well, that's fun. Of course, it doesn't move it where I want to move it. Okay, so we have time is our X, distance is our Y. Oh, I guess the jet car distance would have been up here. Okay, anyway, so the very first point would be 5. The distance would be 200. So this jet car at 5 seconds travels 200 miles. Holy moly, that's going super fast. At 10 seconds, it has traveled 400 miles. At 15 seconds, it has traveled 600 miles. And at 20 seconds, it has traveled 800 miles. So I bet you could guess what would be next. For every 5 seconds, it looks like we are adding 200. So if you wanted to know how far the jet car traveled in 25 seconds, the answer would be 1,000, right? So we're going to be learning how to look at the information in a table and in a coordinate grid and figuring out how to answer it. So we know that this jet car is super, super fast because I don't think my car can go 200 miles in 5 seconds. In fact, I know it can't. All right, your classwork is in Google Classroom. Let me know if you need any help with it.